Hello, my name is Bruce Reimer. I'm with Strategic 3D Solutions. Today, we'd like to show you the first step in a reverse engineering process, and specifically that means 3D scanning a part. And for this demonstration, we'll be using the EinScan Pro HD 3D scanner with the integrated turntable and tripod. And for this demo, we've selected a part that fits nicely on the turntable. And in this case, I've got it oriented and positioned with a small block of clay. May not be able to see that too well. That's just holding it in position and keeping it stable as the turntable makes its rotation. When you launch the EinScan software, you see the screen that's presented before you. And there are 3 scanning modes, and today we'll be using the fixed scanning mode. We'll do a left click on the fixed scanning mode icon, which loads the next screen. And from there, you have a choice of either opening a new project or opening a project that is already in existence. You just like to add some more scanning to that project. In this case, of course, we're going to open a new project. I'll give it a new name. You can call it whatever you want. I'm just going to call it Reverse Engineering Demo 100. That'll create a folder by that name and load a page where you can decide whether you want to do a color scan or a texture scan or a non-texture scan. In this case, we're really not interested in color information. We just need the features and the geometry of the part. So we'll leave it set as a non-texture scan. When we click apply, it loads the screen where several scan settings can be set to your liking. Perhaps one of the more important ones is the brightness of the light source. And you see that scaled here. The objective at setting this is to have just a little bit of redness on the surfaces to be scanned. So right now it's set about right. Let me just show you that if you click a selection quite a bit higher, it gets really hot. All these red surfaces are not going to scan well. Similarly, if you go clear down to the low end, it's going to be too cool and probably won't scan very well there as well. So we can set it somewhere in this vicinity, probably just one notch up from that. And I think that's going to scan pretty well for us. The next setting below that is called HDR. That's only really applicable if the part you're scanning has both light surfaces and dark surfaces. And here we're pretty uniform. We're just going to leave that turned off. We are using the turntable that's already turned on, and we'll leave that. And with the turntable, there are 3 different modes for alignment. It's currently set to use the coded targets that were applied to the surface of the turntable at the factory. And that's what we'll plan to use today. But just real quickly, I'll show you the other 2. One is to use the features of the part. So in this case, we've got a fair amount of geometry in this part, and that would certainly work well for this scan. And the last one is to use reflective markers. So if a part is too large for the turntable's targeted codes to be visible to the scanner, then either one of these other 2 methods are certainly good choices to consider. But in this case, we're going to leave it set at the turntable coded targets. And then the last selection to make is how many stops would you like the turntable to make in its rotation as it does 1 revolution. The range of possibilities is between 8 and 180. I generally use 8. I sometimes will go to 10 or 12 if a part is particularly complex geometry. But we'll use these settings as we've got. And now we'll look over here to the upper right-hand corner of the screen, and we'll just do a left click on the Start Scan button. After clicking that, you'll see that the scanner indexes 45 degrees and takes a single shot, and then advances another 45 and does that in succession until all 8 spots, all 8 stops are scanned. As it does that, you see the update happening on the display, and you'll note the white dots that represent the location of the coded reflective targets on the surface of the turntable. It's in that last 8 scan location now, and when that finishes, it automatically takes you to a screen where you can edit out any unwanted data, as, for example, the block of clay. It did show up, and we're just going to highlight that with the lasso tool, delete that, and that should take care of our editing. When you're satisfied with your edits, you can click the check mark at the lower part, and there we have the surfaces that were scanned with that. But obviously we didn't get everything scanned. So we're going to do 2 more part orientations to capture the rest of the part. We'll use the same settings, do a left click on the Start Scan button, and it'll go through the exact same process of indexing 45 degrees, taking a scan, and continuing that process until all 8 positions have been scanned. And of course, I've chosen an orientation that overlaps a fair amount with the first group of 8 scans, as you want to give the software a really good opportunity for self-aligning the second group of 8 with the initial group of 8 scans. And as before, when this last position is done, it will take us to the edit screen. There we have it. There's really no extra data to delete there. And by the way, one of the nice features of this particular scanner is that none of the surfaces below the plane of the turntable are scanned or captured during the scanning process. Really nice feature. We'll accept the opportunity to edit, and you can see it automatically self-aligned those 2 sets of 8 together. So we're almost there. We have just a few unscanned surfaces. We'll do 1 more rotation, 1 more scan, use the same scan settings, left click on that Start Scan button, and go through the same process. And as before, when it completes these 8 single snapshots, this third group of 8, they will automatically be aligned to the first 2 sets of 8. EinScan Pro is doing a really nice job here, getting us very complete capture on these surfaces. And there we have it. Again, we'll accept with the check mark. And there are all 3 scans aligned very nicely together. The next step is to do what's called global optimization. It's just doing a final alignment of the scans. We'll accept that. And then we just need to mesh the model. There's an icon down at the lower right. We'll left click on that. Then there are several settings here. You can double check if the recommended parameters have been set. In this case, they are, and we generally accept about 95% of the time those settings as they are. The major decision at the top is, do you want this to be an unwatertight model or a watertight model? In the case of the watertight model, the software will certainly fill up all of the voids and make it completely manifold, meaning if you were to 3D print that from that model, it would definitely pass all of the integrity checks that are required for 3D printability. But for 3D scanning purposes, I generally never check the watertight option here. I use unwatertight because I really don't want to rely on any information that maybe was generated by interpolation or extrapolation from the actual data. I want to use the actual scan surfaces alone. So we'll leave it at unwatertight, use the recommended parameters, and hit apply. So it takes just a minute to crunch on that data to create the triangular mesh, and then you'll see the result when that step is completed. And you can see we've got a really fine looking scan. Nice job. We'll confirm. And then the remaining step is simply save the data. So we're going to go to that same file location where we were working. There it is. I'm going to scan down, find a file name that's pretty close to what I want to keep, but I try to keep the naming conventions consistent so I don't get lost. Now, there are 2 broad categories of file formats that can be exported. The first is just a point cloud. The raw form of the data is an ASCII cloud, and you can check that if that's something you want to work with. For me, in doing reverse engineering, I'm really looking for a mesh file. And because we did a non-texture scan, it defaults and automatically checks the STL file format. You could save 1, 2, 3, or 4 file formats all at the same time if you like, just by clicking these additional boxes. The OBJ, PLY, and 3MF are all additional mesh file formats. Had you selected a texture scan or a color scan, then the default check mark would have been placed in the OBJ file format, not STL, because STL doesn't save color information. So we'll use this file name, we'll save the STL file, click save. And then there's one additional selection one can make. If you want to save it at any other size other than full scale, you can adjust that here. I always save my files at full scale, 100%. We'll hit apply, and the file has been saved. We've got a beautiful scan, very well suited for reverse engineering. We're good to go. Well, thanks so much for your interest. Again, my name is Bruce Reimer with Strategic 3D Solutions. If you have any questions about this process or the EinScan product line, please get a hold of us. We're happy to help. Hope you all have a really great day. Thanks again for joining in.